the local school board sent out this note to the parents saying, hey, we're having some real problems funding the school lunch program because we're losing lots of money. And the issue really was that the requirements for making a healthy meal isn't what's going to make the students eat. And in the end, the place is run like a restaurant. And so when you don't have the folks there to eat the meals, then the place loses money.
You really don't realize how much science goes into making sure you really get enough of what you need throughout the day through these meals. So even though you may want, let's say, pizza every day of the week, you find that the caloric requirements aren't met by just pizza every day. You find that you have to kind of vary the meals a bit. You have to make sure you meet all the different requirements. And at the end of the day, you also have to make sure that kids actually eat the meals.
The idea is to come up with a variety of meal plans that satisfy the nutritional requirements, meet some questions of taste that the students prefer, and also stay within a fixed budget, which doesn't allow for an awful lot of freedom in the choice.
One of the neat tools of mathematics is this idea of solving an optimization problem. What's the best way to do something? And typically when those get phrased, what you have is a situation where you can say, I think I know what's best, but then I also have constraints on my problem. And so there's a natural language in mathematics to deal with these problems. And this one really it's driven by the constraints. So the person who runs that cafeteria, no doubt in my mind, they know how to make food that would be good for the kids and that they would like. They just might not have the money to do that.
For part one, where we were asked to develop a model to predict how many calories a student would need at lunch, we considered many variables that go into how many calories a student actually needs, whether it be his or her gender, their age, their body mass index, which is their relationship between their height and weight, how much sleep they got in the morning, whether they ate breakfast or not. So all of these factors went into our part one model.
Basically, we made a graph of your day and when you're sleeping, when you're working out, when you're in class, how many calories are you going to burn? What's the rate? And basically what you do is you just integrate under that function to see how many calories you need to eat during what time of the day.
The unique thing about our solution was probably the negative calorie aspect, because it's possible, according to our model, it's possible to have negative calories. See, for example, if you had a really big breakfast, you're not going to need as many calories from lunch, so it can go all the way into the negative values. I think that was pretty interesting.
Many teams were able to find some sort of approach in order to attack problem one, which was this idea of how many calories does a student need, right, for their lunch. So I thought that was great to see so many teams able to jump right in, get answers.
In part two, we were supposed to extrapolate our model from part one to apply to the whole nation to see, does our model show students are actually being covered in the plan? And we found that with our solution, only 10% of students are actually adequately covered by an average school lunch.
One size doesn't fit all. I think they had to consider caloric intake of males and females differently, physical activity, again, whether or not they ate breakfast.
Although it's a great plan in idea, we find that 750 to 850 calories is not nearly enough for most students, even elementary school kids.
Part three asks us to create an actual meal plan for schools during lunch. So if we were given a budget of, say, $7 a week, would we be able to develop a lunch plan that not only satisfies federal guidelines, but also satisfies students' taste?
The modeling part they handled much easier, but when it came to something more nebulous and individual like taste and preferences, that was hard.
How do you quantify taste, for example? A very difficult thing to do, and so there are a number of approaches that were presented today in which teams use surveys, or they created these samples, or they quantified taste based on different metrics.
When we looked in the literature, we found that our taste is composed of 5 major things. And when we break those down, only 3 of them really stand out when you compare them to each other: sweetness, sourness, and saltiness. So in order to analyze each taste, we found a real equivalent. So we found that we use sugar, we use calcium, things like that, physical things that we could measure in order to quantify so-called taste.
By the time you get through, and we called out the top 6 here today, made for a very challenging weekend for the judges, and very satisfying, because we see quite a few students in American high schools who have taken the challenge of doing good work in mathematics and applications of mathematics to real-world problems and really done something solid with that.